While Desmos is great for interpreting functions and analyzing graphs, one other great usage of it is to help us with percentages. When we start typing in percentages, let's say 40%, Desmos will automatically input of. So 40% of, let's say 50, ends up equaling 20. Now we can use that to directly solve many SAT questions. For example, what is 90% of 80? We just type 90%, we get the of, 80 equals 72. Simple. Now we could flip that around. What percentage of 40 is 15? So we could just take 62.5% of 40 and see if that equals 15. And it does not. It equals 25. And then we could just try down the list until we get something that matches, like 37.5. And that does equal 15. Boom, done. Now we could also do percent increases or decreases. What number is 1% greater than 7,000? Well, we could take 1% of 7,000. So 1% of 7,000, which is 70. And then we just add that to get 70. Desmos is also great when we are dealing with percentages that might be greater than 100 or just intimidating for one reason or another. What is the result of increasing 300 by 200%? So we could take 200% of 300, and that's 600. So if we increase 300 by 200% of 300, which is 600, we get 900. And we can get creative. The SAT likes to ask percentage questions in different ways. For example, x is greater than 0 and p% of x is 13. What is x in terms of p? So remember, x is one of the reserved variables. This is something that clearly we want to use sliders for. So instead of x, let's go with a. So some percent of some number is 13. To make our lives easier, we should probably pick a number that's a multiple of 13. I'm going to go with 52. So let's call a equal to 52. Then p% of a is going to equal something. And because we're dealing with percentages, we probably want our percentages to go from 0 to 100. So we want p% of a, which is x, or in this case we assigned it the value 52, to equal 13 as per the question. So we can slide along until p% of a equals 13, right? So here is p, and we're getting closer, and there we go. P equals 25, and p% of a, which is 52, is 13. So going back to the question, what represents x, which we've assigned the value 52 in terms of p? Well, now we just got to figure out which of these is going to end up equaling 52. So we could do 13p. Nope, that doesn't equal 52. We could do 13p over 100. That doesn't equal 52. We could do 100p over 130. That does not equal it either. Or, sorry, over 13. And then we got 113 divided by p. And that does equal 52, so that is our answer.